Hey guys, it's Jensen, and here is my video or screencast. Uh, as you can see here, this is looks as though this looks like as if it is a simple harmonic. As you can see here, we're try we're trying to get a equilibrium. We haven't really talked about this much in class, but we are eventually are. So we can see that the blue vector O is changing for the green vector, and it starts slowing down. We're trying, and it's showing us we're having the net force is equal to a net restoring force, or meaning trying to say it's trying to be equilibrial with the line. Next we have the circular motion. So we have the circular motion for this one. It says here that we have to move the ball constant speed, and we put this in the circular motion. Now I put this in a circular path, and it's with what we can see here from the screen is that there's the green, which is the velocity, and the blue, which is acceleration, are perpendicular to each other. They have to be perpendicular to each other, and acceleration has to go towards the centers in order for the circle thingy to move in a circle. So let's see. Sorry for the bad framework, I just don't have a really good QuickTime video. But as you can see, it's moving side by side, going up and down. It's really like that. And we can see that the velocity is changing, and the only thing that's changing is the direction. It still has an acceleration, which is constant, but the velocity is always changing because we are changing the direction of it. That's why it's called uniform. It's the same, but the accelerating is towards center. We have that's why we call this a uniform circular motion, because when velocity, the definition for, I guess, what Mr. Day told us is that velocity and acceleration are both perpendicular. And next. Okay, next is we have it's just a line. They're just going back and forth, back and forth. As you can see here, because of the framework, we can't really see it that well. But you can see that the line is just moving up and down, back, side to side, along with an acceleration moving. Yeah, like that. And as you can see here, it's slowing down, so that because the green is the acceleration. While the blue is the velocity. Am I right? I'm actually wrong. It's actually green velocity, and blue is the acceleration. But what it says here, it's just dragging it around, and it's dragging around what we think what it is. It just shows us that it speeds up and slows down, and it speeds up again and it slows down, speeds up and slows down. You can see that from the green, if I can just yeah, if this is just, yeah, as you can see here, like right here, green. If it's a green, it's starting to speed up. Then eventually it's gonna slow down. So here we are again, and here's the last one. We're given this one. Sorry for the background though. There's gonna be background noise. As you can see here, don't mind the noise, please. As you can see here, because of the framework and because of my slow computer, we are given that that they are moving slightly, moving across the saw, because it says right here we have to jerk or go back and forth. Well, what I try to do is I try to make it look as different as I can, or trying to relate it to what relate it to what acceleration and velocity really shows. Lastly, here's the worksheet. So I'm just gonna read it out, the answers. For number 1, it's just asking me to make observations. So here's the green we met, which is the velocity, and the blue, which is the acceleration. and we're given that. So what we tried to is we're just doing things or moving towards a forward motion or going out or on opposite direction. Number two, what color vector arrow represents velocity? Well, green, orange. As we can see here, so the green is velocity, and blue is acceleration. Sorry, blue. Yes, so blue is velocity. Green is velocity, blue is acceleration. And number three is try dragging the ball around a circular path. What we see is that the blue and the green vectors are perpendicular. So and that's what universal motion, circular motion is. Like what I said a while ago, speed is not changing, but it's still accelerating, and the velocity is changing because they're changing direction. Here, the vector number four is that we can show that the slow constant speed. The vector blue is a lot since there's no acceleration. Number five, what happens to the vector when you jerk the ball rapidly back and forth across the screen? One, if it goes to the side, if the thing goes right here, like to runs right here to the right, the acceleration will go down. Once we stop, it starts slowing down, so the acceleration will go opposite from the velocity, so that you can stop. Number six, circular bottom. That's what I just said. You have, I have a uniform circular motion because velocity and acceleration are perpendicular, and green velocity has a direction while it's moving. Let's keep going round and round and round and round. And 7 is simple harmonic, which is the first one we did. It's just basically a restoring force or a net force. It's trying to have an equilibrium of speed. See you guys.